Welcome to AGI-CORE-Pro, our multi-model AI video routing framework. In this session, we will use Python and the google-genai SDK to orchestrate specialist video models. The material is provided free through DDS Vibe Academy, focused on practical, production-grade AI video systems. Traditional monolithic video models charge a flat premium, for example, 40 cents per second, regardless of task complexity. AGI-CORE-Pro replaces this with a routed pipeline. Lite for basic clips, fast for latency-sensitive work, and standard for high-fidelity tasks. This paradigm shift aligns cost with actual requirements. Model releases and price changes now arrive in rapid bursts. This timeline shows Lite shipping, legacy endpoints being removed, and fast receiving a price cut within 1 week. Without elastic routing, every such change forces code rewrites. Our goal is to absorb this avalanche through configuration, not refactoring. Here we map the Veo 3.1 family. Standard targets premium 1080p and 4K at the highest price. Fast offers mid-tier performance at a reduced rate. Lite delivers the lowest cost for everyday workloads. Understanding this matrix is essential for routing each request to the most economical viable tier. Constraint-aware routing begins with the incoming request. If the job requires 4K or reference images, we route to standard. If latency is critical, we select fast. All remaining generations default to Lite. This simple decision tree enforces policy while minimizing both latency and spend. We first define a model registry. It abstracts concrete model IDs behind a central dictionary. This allows us to swap specialists or pin April 2026 preview endpoints without touching caller code. The registry becomes the single source of truth for every operational tier in the system. Next, we implement the tier routing function. It inspects constraints such as resolution, presence of reference images, and latency sensitivity. Based on strict rule evaluation, it returns the appropriate tier, always falling back to Lite by default. This keeps routing logic explicit, testable, and easy to extend. With routing in place, we integrate the google-genai SDK. Our dispatch function resolves the tier, looks up the model ID from the registry, and calls generate videos asynchronously. Your application remains clean. It only specifies prompts and constraints, while the dispatcher handles model selection and execution. Production systems must tolerate API failures. Here we wrap dispatch in a safe dispatch function that applies exponential backoff and tier downgrades. On repeated errors, we sleep, then retry on a cheaper tier. This resilience protocol ensures eventual delivery without overwhelming upstream services. Reference consistency is critical for narrative video. Naive text-to-video often drifts character identity across frames and clips. By contrast, reference-locked workflows preserve the same hero design throughout a sequence. This is mandatory for procedural pipelines, branding, and long-form storytelling. We address this by pre-generating a hero reference with Nano Banana Pro. A simple helper function creates a single image from a prompt and stores it as a static asset. This baseline identity is then reused across all subsequent video generations, anchoring the character's appearance over time. To animate our hero, we pass the saved reference image into Veo 3.1 standard. The animate reference function injects the file into the reference images configuration. Veo consumes up to 3 such images, enabling rich motion while strictly preserving subject identity across every generated frame. The same pattern powers product video variants. We feed a static product photo and choose an aspect ratio based on channel. 16.9 for storefronts, 9:16 for social feeds. Veo Fast then generates cinematic motion assets automatically, giving marketing teams channel-ready content from a single source image. Routing efficiency compounds quickly. Tier routing alone, using an 80-15-5 blend across Lite, Fast, and Standard, yields roughly a 4-fold cost compression. When combined with caching, reference reuse, and compression, the full-stack architecture can deliver over 12,000-fold effective efficiency gains. Every dispatch produces a rich payload and telemetry record. Inputs capture constraints such as resolution, aspect ratio, references, and budget usage. Outputs record the assigned tier and exact model ID. An execution trace log tracks retries and fallback paths, enabling precise monitoring and optimization. A key safeguard is defaulting to the cheapest tier and enforcing budget circuit breakers. We continuously monitor budget-consumed PCT. When it exceeds 90%, we override the planned tier and force routing to Lite. This simple rule prevents runaway spend while keeping the system operational. Deprecated preview endpoints are a common failure mode. After April 2nd, stale Veo 2.0 IDs begin returning 404 errors. The remedy is architectural. Pin current Veo 3.1 preview IDs inside the registry. Updating a single configuration entry then restores service across the entire pipeline. Under production load, missing fallback logic leads to repeated timeouts once API rate limits are hit. By implementing a structured fallback chain with exponential backoff, we transform failure into graceful recovery. Traffic briefly pauses, then resumes on lower tiers without overwhelming the provider. API rate cards are moving targets. Prices can spike late in the billing cycle, driving unexpected cost jumps. To mitigate this economic vulnerability, we verify live pricing continuously and pair it with budget circuit breakers. The result is a stable cumulative spend curve, even as rates fluctuate. To ship AGI-CORE-Pro, complete 3 steps. Pin current model IDs and validate live Gemini pricing. Wire fallback logic, back-off timers, and budget caps. And choose between Direct Gemini API or Vertex for Enterprise IM. The entire curriculum is free and open. No paywall, sign-up, or certification required.